Hello, everybody. So what we're going to be looking at today are negative exponents. And the idea of a negative exponent should be really weird from the standpoint of looking at this, that exponent means it's 3 times 3 times 3. This exponent says take the number in the bottom, multiply it that many times. So 3 squared is 3 times 3. 3 the first is just 3. Well, even 0 should be weird. How do you multiply it by itself no times? How do you multiply it by itself a negative number of times? So this idea should be weird of how to get this definition that's in your head to apply to this stuff. Well, if you look at it this way, I'm going to go from this one to the one that's below it by dividing it by 3, and I get this one. So I'm going to divide this one by 3 to get that one, because that cancels out, that cancels out. I'm going to divide this by 3 to get this one. And what's it worth? 1. Let's try it on the calculator. 3 raised to the 0 power. 1. 526 raised to the 0 power. 1. In parentheses, negative 28 raised to the 0. 1. Anything to the 0 power is worth 1. Now there is one exception. I'm whispering it. Okay? Shh. There's one exception. 0 to the 0, it blows up. Okay? So anything to the 0 power except, whoops, I got it the other way around. Anything to the 0 power except 0 is 1. Pi to the 0 is worth 1. 9, 8, 7, 6, 5, 4, 3, 2, 1 raised to the 0 power is worth 1. Okay? Except 0. 0 to the 0 it doesn't work. Anything else, it's worth 1. Why? Because of this idea right here, how I explained that. Now, to get the next one below it, well, what does it mean to be raised to the negative 1? Well, I'm going to divide this by 3 to get this answer, which is 1/3. 3 to the first. So can you guess? When I divide this by 3, what do I get for that? It's 1/3 squared. So a negative exponent upstairs means take the sucker to the bottom and make the exponent positive. So you get 1/9. That's all it means. It doesn't change the sign on the number. It's still positive. This exponent that's negative has nothing to do with the sign on the number. Okay? In other words, it says take the reciprocal of it. All right? So what if it's downstairs? Well, guess what? Take it upstairs. And the exponent's now positive. I'll prove it to you. So we know that's worth 25, right? 1/5 to the negative 2. 1/5 raised to the negative 2. Whoops. I didn't look at what was over there. 1 divided by 5 raised to the negative 2. 25. If it's downstairs with the negative exponent, take it up. If it's upstairs with the negative exponent, take it down. So this one, it's upstairs, bring it down. This one's downstairs, bring it up. So the one that's in the bottom comes up, and one that's in the top comes down, and this one had a positive exponent, it stays put. Okay, so I have x to the first upstairs, x to the 12th downstairs. And what we did just in the last lesson is you subtract your exponents where there are more of them. So 1/x to the 11th. There you go. This has a negative exponent, take it downstairs. All of these have positive exponents, so they stay put. And when you move it down, you have to keep a placeholder upstairs to indicate all this stuff is down. So you put it over 1. Now x cubed y to the eighth y squared. Now simplify it. 1 over x to the ninth y to the 10th. There it is right there. Okay. Both of these come down. And you have to have a placeholder upstairs to say that stuff came down, but nobody came up. So x to the first is down, x to the second is down. That had a positive exponent, so it stays put. If your exponent's positive, don't move it. It doesn't matter where it is. If the exponent's positive, don't move it. So that's 1 over x to the sixth. That has a positive exponent. Leave it alone. These move. This one comes down, and this one comes up. So I have x to the sixth, x to the fifth, over x to the eighth. So the top is x to the 11th over x to the 8th. You're dividing, so subtract your exponents where there are more of them, and you get x cubed. So this one right here. Everybody switches. This one comes down, this one comes down, that one comes up. So I have x to the fifth upstairs, and both of those are now downstairs. You could think of it as just, hey, this is the same, I'm just going to cancel that out to indicate that there's still somebody in the bottom. There it is. Okay. Exponents on these are 1. This has a negative exponent, so it's going to come down. So I have x cubed upstairs. This x to the negative 4 comes downstairs as x to the fourth. Those stay put. These I need to subtract. There's more on the bottom. So I have y squared over x to the fourth minus 3. So that's y squared over x. Okay. Let me erase this. Kind of crowded that one. So y to the 8th stays put because its exponent's positive. X to the 7th stays put because its exponent's positive. This x to the 5th comes up, and that y to the 8th stays put. Okay? So y to the 8th over y to the 8th. Those will just cancel. It's this. It's y to the 8th over y to the 8th. It's whenever you have the same thing on the top and the same thing on the bottom, don't they just cancel out or give you 1, whichever way you want to look at it? Boom, they're gone. So I've got x to the 5th over x to the 7th. There's more on the bottom than the top, so do the subtraction on where there's more of them. So I have 1 over x squared. There it is. So that's the name of your assignment. Thank you for your time. Have yourself a great one.